mathematics class. Today we are going to discuss the continuity and differentiability for plus 2 students. First we move to continuity. What is continuity? For this we consider three graphs. The first graph, there is a ring or jump in the graph, therefore it is not continuous. What about second? It is clear that there is a break in the graph, there is a gap in the graph, therefore it is not continuous. If we pass to third graph, it is a smooth curve, therefore it is continuous. From this we conclude that continuous means there is no jump or break in the graph, then it is continuous. Or continuous is always a smooth curve. That means we can draw the graph without lifting pen. Such graph shows continuity. To derive a formula for continuity at a point, we pass deeply through the graphs. For this, take a point A in its domain. In the first graph, it is clear that limit x tends to A left of f of x equal to limit x tends to A right of f of x. But it is only disjoint at the value of A, which is not equal to f of A. Therefore, the function is continuous. That is, LHL equal to RHL, which is not equal to f of A. That is the one of the condition for discontinuity. In the second graph, it is clear that the left limit at A and right limit at A are not equal. Therefore, LHL not equal to RHL. Therefore, the function is not continuous at A. If we pass to third question, it is clear that limit x tends to A f of x and f of A are equal. Therefore, the function is continuous at x is equal to A. In short, if f of A is finite, then f of x is continuous at x is equal to A. Finite means f of A not equal to 0 by 0. If a function is not continuous, is called a discontinuous. Discontinuity occur in two different ways. First one, limit x tends to A minus f of x not equal to limit x tends to A plus f of x. That is, LHL not equal to RHL. Then the function is not continuous. Second one, LHL equal to RHL, which is not equal to f of A. That is, limit x tends to A f of x not equal to f of A. Then also the function is discontinuous at x is equal to A. This point A is called point of discontinuity, and the second type of discontinuity is called removable discontinuity. What is it? Removable discontinuity. Continuity in an interval. If a function fx is said to be continuous in given open interval AB, then it is continuous at all the points in open interval AB. If a function is continuous at all the points in its domain, then we say that a continuous function or continuous everywhere. Algebra of continuity. If f and g are continuous functions, then f plus g, f minus g, f into g and f by g are continuous. Some continuous functions. There is no need for the proof, but we remember these concepts to solve the problems. Polynomial functions are continuous in capital R, set of real numbers. Constants functions are continuous in R. Modulus functions are continuous in R. Trigonometric functions are continuous in its domain. Inverse trigonometric functions are also continuous in its domain. Prove that the function f of x equal to 5x minus 2 is continuous at x is equal to 3. Let's see the answer. Given that f of x equal to 5x minus 2, we have to check the continuity at x is equal to 3. Find f of 3 which is equal to 5 into 3 minus 2, that is 15 minus 2 equal to 30, comma a finite number. Therefore, f of x is continuous at x is equal to 3. Find the point of discontinuity of f of x is equal to 2x plus 3 if x less than or equal to 2, 2x minus 3 if x greater than 2. Let's see the answer. Here the function 2x plus 3 if x less than or equal to 2 and 2x minus 3 if x greater than 2. So we have to check whether the function is continuous or not at x is equal to 2. For this, we find LHL and RHL at x is equal to 2. If both left and right limits are equal, then we find f of 2. For this, first find LHL, that is limit x tends to 2 minus f of x, that is limit x tends to 2. 2 minus means x is tending to 2 through left. Left means x less than 2. Then the function is 2x plus 3. Then LHL equal to 7. RHL means limit x tending to 2 right of f of x. 2 plus or right of 2 means x greater than 2. When x greater than 2, the function is 2x minus 3. Then RHL equal to limit x tends to 2 to x minus 3. Put x is equal to 2, then it becomes 1. Here LHL not equal to RHL, which implies the function fx is discontinuous at x is equal to 2. Find the point of discontinuity of f of x is equal to mod x by x if x not equal to 0, minus 1 if x equal to 0. First of all, we rewrite the given function f of x as if x less than 0, here the mod x become minus x by x, that is minus 1, and if x greater than 0, mod x is x by x equal to 1, and also given when x equal to 0, value of the function is minus 1. Now, to find whether the function is continuous or not, we have to check the left limit and right limit at x equal to 0. So, LHL equal to limit x tends to 0 minus f of x. 0 minus means x is approaching to 0 through the left side of 0. Left means x less than 0. When x less than 0, the function is minus 1, that is a constant. Limit of constant is constant itself. Then RHL is again limit x tends to 0 plus f of x. 0 plus means x tending to 0 through right of 0. Right means x greater than 0. Then limit x tends to 0. When x greater than 0, the value of function is 1. Limit of constant is constant itself. So, LHL is minus 1 and RHL is 1. It is clear that LHL not equal to RHL. Then what is the conclusion? If LHL and RHL are not equal, then function is not continuous. That is, f of x is not continuous at x is equal to 0 or x is equal to 0 is a point of discontinuity. Find the relation between a and b. If the function f of x is equal to ax plus 1, if x less than or equal to 3, and bx plus 3, if x greater than 3, is continuous at x is equal to 3. Since the function is continuous at x is equal to 3, then LHL and RHL are equal at x is equal to 3. What is left hand limit LHL? That is limit x tending to 3 f of x, where f of x is x less than 3, the function is ax plus 1. Put x is equal to 3, then it becomes 3a plus 1. What is right hand limit RHL? That's equal to limit x tending to 3. When x greater than 3, the function is bx plus 3. Put x is equal to 3, then it becomes 3b plus 3. Since the function is continuous, what is it? Since the function is continuous, then LHL equal to RHL, that is 3a plus 1 equal to 3b plus 3. So 3a minus 3b equal to 2, which is the required condition. Find the value of k for the function f of x is equal to kx square if x less than or equal to 2 and 3 if x greater than 2 is continuous at x is equal to 2. Since the function is continuous at 2, then LHL and RHL at 2 are equal and these equal to f of 2. So, what is LHL, left hand limit? That is limit x tending to 2 through the left of f of x, that is limit x tends to 2 minus f of x can be written as limit x tends to 2 when x is less than 2, the function is kx square. Put x is equal to 2, then it becomes 4k. 2 square equal to 4, 4k. And RHL, that's equal to limit x tends to 2 through the right of 2, that is x greater than 2. What's the function? 3. Then it becomes limit x tends to 2 plus 3. 3 is constant and limit of constant is constant. Since the function is continuous, since f of x is continuous, then we say that LHL equal to RHL. Therefore, LHL is 4k and RHL is 3. Therefore, k equal to 3 by 4. Find the value of k for which the function f of x is equal to k cos x by pi minus 2x if x not equal to pi by 2 equal to 3 if x equal to pi by 2 is continuous at x equal to pi by 2. Since the function is continuous at pi by 2, then left limit equal to right limit equal to f of pi by 2. So what about left limit? LHL equal to limit x tends to pi by 2 minus f of x. That can be written as limit h tends to 0 f of pi by 2 minus h. Another method to find left limit. Limit h tends to 0, f of pi by 2 minus h. That is, limit h tends to 0. What is f of x? K cos x divided by pi minus 2x. Put x is equal to pi by 2 minus h. K cos pi by 2 minus h divided by, what's the denominator? Pi minus 2 into pi by 2 minus h. On simplifying, limit h tends to 0, k into, what is cos pi by 2 minus h? It is of the form cos pi by 2 minus x, that is sin x. Here x equal to h, then it becomes sin h divided by, expand the bracket, pi minus 2 get cancelled, minus pi, minus into minus become plus, 2 into h become plus 2h. Again plus pi and minus pi get cancelled. What's the remaining terms? That is, limit h tends to 0, k sin h divided by 2h. This can be rearranged as limit h tends to 0, k by 2 into sin h by h. In first year, you already discussed the algebra of limit, that is, limit f into g is limit f into limit g. Here the first function is constant, then limit is constant itself. Second one, limit h tends to 0, sin h by h, that is 1, then limit become k by 2. What is the value when x is equal to pi by 2? Function is 3, that is f of pi by 2 equal to 3. Since it is continuous, LHL equal to f of pi by 2, that is LHL equal to f of pi by 2, that is k by 2 equal to 3. Therefore, k equal to